Hi, this is Dr. Green. In this first unit that we're going to consider, we're going to look at finance, personal finance. And you should be able to develop some good money sense by the end of the unit. I think you'll find that the mathematics part of it's pretty easy, but it's something that you guys have probably not seen before and would be very useful for you. So we're first going to consider compound interest and inflation here. So we have to define some variables. So PV stands for present value, and that is the amount in your account at the beginning of the time period, whatever that is. The future value, denoted FV, is the value of the account here at sometime in the future, so at the end of the time period. APR stands for annual percentage rate, so that's the interest rate for 1 year. And a year is usually your basic time period here. When we use capital R, that's what we call the periodic interest rate, or the interest rate per period. You take the APR and you divide it by M, where M is your interest periods per year. So if you're figuring monthly interest, you're going to divide by 12, for example. And then lowercase n is going to be the number of interest periods, total number of interest periods for your overall time period. So if we have one amount and we want to compound that, we have one starting amount, we want to compound that and see what our ending amount is. That's this formula here. So the future value, the end amount, is the start amount times 1 plus r to the n. So let's see where this formula comes from, and then we'll kind of put it to use here. So at time 0, you have the amount PV, your start amount, and then after one period goes by, you're going to add in your interest. So you're going to take your start amount PV, and then you're going to add, this is your interest for one period, and that's simple interest, which is your principal times rate times time. So your principal is the PV, your periodic interest rate is cap R, and then your time is one period. So this is just PV plus PVR. You can factor that PV out. You'll have 1 left in the first factor right there, and you'll have this R left in the second factor. And then you can repeat that again using this as your new start amount. And if you do the algebra factoring out, you'll get PV 1 plus r squared, and then you'll get PV 1 plus r cubed. So after n periods, you have PV 1 plus r to the n. And if you want to figure the interest earned here, you just take your end amount and subtract your start amount. So whatever you have at the end minus what you had when you started, the difference in it is going to be interest. So let's look at an example here, put this to use. So here, example 1, this is different than the example in your notes, just to give you some extra examples to look at. Your long-lost great-great-aunt passes away, and she leaves you $5,000 on the day you were born. Now, of course, no one told you that you had this money, so it sat for 65 years in an account earning 4.8% interest compounded monthly here. And then I want to know, well, how much can you add to your retirement nest egg at age 65, and how much interest was earned? And then note here, unless stated otherwise, your interest rate is given as the APR. So that 4.8%, that's an APR, not a what's called a yield. So that's what we call a nominal interest rate. So we want to use this formula here. Future value is present value 1 plus r to the n. And so we need our PV, we need R, and we need N. So PV is our start amount. That's the $5,000. And then M is compounding periods per year. And they tell us here that it is compounded monthly. So M is going to be 12. And then our monthly interest rate, which is cap R, we are going to take the APR, which is the 4.8%, do it as a decimal, 0.048, and we're going to divide that by 12. And if you compute this, you get 0.004. And then N is going to be the total number of interest periods. Our interest periods are months. So we've got 65 years times, let's see, better do that in math mode, 65 years times 12 months per year, which is 780 months. So now we're ready to go ahead and plug into our future value formula. So our present value is the 5,000, and then we're going to multiply by 1 plus our periodic rate, 0.004, and then our exponent is the 780 here. And we'll compute that. There's scientific notation. Let's get some more decimal places here. Let's try that one more time. So let's see, rounded, that's going to be 40 cents, rounded to the nearest penny. So you've got $112,529, $112,529.40. Ah, that's a lot of money. $5,000 turns into $112,000. And that's exponential growth. This is an exponential. The variable's in the exponent, and exponentials grow really fast. So your interest earned here is going to be your end amount there. And then we're going to subtract off the 5,000 that you started with. And when we do that, we get 107,529. So almost all of this 112,000 is interest. Just the original 5,000 was not.